Welcome to this channel. In today's video, I'm going to be explaining about the structural component of bridges. A bridge is a very important structure in civil engineering, and it is important for us to understand the structural components that are made up of bridges, their importance, and the purpose in which they serve. So first, let us talk about what do we mean by a bridge in a structural terms. A bridge is a structure that connects two points over a barrier. So any structure that connects 2 points over a barrier is called a bridge. This is in a layman term. So, and this barrier can either be a water bodies in terms of rivers, lakes, oceans, and all of that, or it could be an intersection of roads or intersection of highways, or it could be over different highways or railway lines or bodies or utilities. So whenever you have a structure that connects 2 points over a particular barrier, so that kind of structure can be termed as a bridge. So in civil engineering, we have various types of bridges depending on different categories. You can have classification based on function, classification based on the type of material, classification based on supports, and all of that. But what is more important to us as engineers is the structural mechanism that make up of the bridge. So that is why, as an engineer, we usually classify bridges into these different classifications. So we can have beam bridge, arc bridge, cantilever bridge, truss bridge, suspension bridge, cable stayed bridge, movable bridge, and floating bridge. So you can also have other cases of bridges, maybe based on the material in terms of either it is made of timber, reinforced concrete, of pre-stressed concrete, or of steel. So but what is actually important is the structural component. So this is the various types of bridges that we have in engineering. So in order to understand the component of bridges, this can be subdivided into three main parts. So any type of bridge, either beam bridge, arc bridge, cantilevered, truss, cable stayed, and all of that, they are mainly subdivided into three major structural parts in terms of the structural components. So the first of them is the superstructure. Then we have the substructure, and lastly we have the appurtenance. The main structural parts are the substructure and the superstructure. The appurtenance is not actually a structural component of bridge, but it is also important for the functionality of the bridge. So let us look at this component one after the other. We explain it and then we give various examples of this component. But before we start explaining what these components are, if you want to learn more about structural design, you can check out our website chefjinacademy.com, and then we also have some courses on Udemy as an international student. If you want to take our courses on Udemy, I will leave the link in the description of this video. So for the superstructure is usually the structural component of a bridge that is above the bridge bearing. We have something we call bearing in bridges. So in the next slide, I'm going to explain what we mean by bearing. So what divides the superstructure and the substructure is the bearing. So the main purpose of the superstructure is to provide a base for the moving vehicles in terms of if the bridge is an highway bridge, or for trains, or for pedestrian in terms of if the bridge is also serve as a pedestrian access. Or what made up the superstructure of a bridge include the surfacing. This surfacing can either be wearing surface, either asphalt, or in case if asphalt is not used, if you are using a rigid pavement where there is no asphalt at all, then whatever the surface is. Then we have the deck. The deck is the slab that serve as the actual base. So if you look at this image, you see the deck. So this is the deck where the slab that actually takes that serve as the base. Then we also have the primary support member. The primary support member is the actual member that support the bridge. You know, in the previous slide, I talked about different types of bridges. We have the beam bridge, cantilever, trusses. So what we mean by primary support member here are the actual member that support the bridge. In terms of truss bridge, the truss itself is a primary member. In terms of cantilever arc bridge, the arc itself is a primary member that support the bridges. And then we also have the secondary members. Secondary members are bracing members. So these bracing members are just provided to prevent some kind of movement in the minor direction of the bridge and to provide stability. So definitely, substructure consists of the decking, the primary member in terms of if it is a arc bridge, the arc itself, if it's a truss bridge, the truss itself, and all of that, and also the secondary member that also assists the primary member in supporting the bridges. So this image, you can see that below the bearings, so these symbols that indicate support is just like a bearing in practical sense. So anything above it is called the superstructure. So let's now talk about the bearing. So the bearing is this bearing is not always common in all bridges anyway, depending on the assumption and the kind of design and connection you want to have between your superstructure and the substructure. So the bridge can be present or it might not be, the bearing can be present and it might not be present, and the bearing can come in different forms. So what do we mean by a bearing in bridges? A bearing is just a mechanical device that is placed between the superstructure and the substructure. It's just like a receiver. So like I've mentioned 3 main points in which a bearing, the purpose in which bearings serve in bridges. It connects, that is, it connects between the superstructure of the bridge and the substructure. Most of the time, it receives the primary and the secondary supporting member. So let's say this bridge here is like a beam bridge. That is, the main primary support is the beam. So you can see this black symbol here, or this black image here, is the bearing. So this bearing, if it is a concrete bridge or a bridge made of concrete, either reinforced concrete, pre-stressed concrete, most of the time we use the elastometric bearing. Then another purpose that bearing serves is it transmits the load from the superstructure to the substructure. You know, since it connects, therefore it has to transmit load, and then it also allows for some movement, translational movement, and some rotational movement. This is usually done where there's no rigid connection between the superstructure and the substructure. So these are the main purpose of the bridge. In terms of a steel bridge, so this is how your bearing is going to look like. So the second image is showing an elastometric bridge. The last image below is showing for a steel bridge how the bearing is going to look like. So the main purpose of bearing, to recap, is to connect, to transmit load, and also to allow some translational and rotational movement. I know you are enjoying this content, so if you want to see more of this, you can subscribe to the channel. You can even share this to your friends so that they can also learn from it. This channel is also trying to grow some community, so you can join our community in order to learn more about civil engineering design. The second component is the substructure. As I've mentioned, the substructure is the structural component below the bearing level. After you have the bearing, every other thing in that are structural part are called the substructure. So their main purpose is to support the superstructure and transfer the load to the soil. So the substructure consists of abutment, the piers, and the foundation. So just to explain what an abutment is, you can see that from this image. So the abutment is just like the end support of the bridge. You usually have abutments. It is usually designed as a retaining wall abutment. So it serves two purposes. It takes the load and also retains some earth. You can see some earth attached to the abutment. So at the start of the bridge and at the end of the bridge, you usually have an abutment. So as I've mentioned, their main purpose is to retain earth and also to support the superstructure at the beginning or at the end of the bridge. Then we have the piers. Piers can be seen as a column. The columns that support the superstructure. So usually when you have the abutment at the start and end, the middle support or the intermediate support of the bridge, the vertical support, are called the piers. They also support the superstructure. Then lastly, the component of substructure is the foundation. So the purpose of the foundation is to collect the loads but from the superstructure and the piers and also the abutment to collect all this load and transfer it to the subsoil. So foundation for bridges are usually deep foundations, but we can have some rare cases where we provide shallow foundation like rafts or big piles, big pad foundation. So but generally for bridges, the kind of foundation we provide are pile, deep pile foundation. So if you look at the image to the right, you see the identification of the abutment at the start of the bridge. Then you see a piers, which is a middle column that is supporting the bridge. And then you see the foundation that transfers all the load from the superstructure, the abutment, and the piers into the soil. Then the last structural component, or the last component we are going to be talking about, is the appurtenance. As I've mentioned, the appurtenance is not really a structural part of the bridge. Structural part in the sense that it is not supporting the bridge loads, but they are needed for the functionality of the bridge. So simply put, in a layman, an appurtenance is just a part of the bridge. Not necessarily part of the bridge. It can even be part of the bridge site, the total site of the bridge, which are not structural components but serve in the overall functionality of the bridges. So example of this appurtenance are embankments. Embankment is important, especially at the start and at the end of the bridge where we have the abutment. So you need to provide embankment and slope protection structures. So these are appurtenance to support the bridge and also to prevent soil failure. So this image is showing a typical example of a slope protection. So you can see this structure here beside the piers. So this slanted member is like a slope protection to prevent the soil from failing in this region. So these are one of the part of abutment of a bridge. And another example of an abutment is an approach slab. The approach slab is the slab that provides a smooth transition from the traffic highway surface to the bridge surface. Usually the bridges, as we've defined it, they provide a movement across barriers. So usually it starts from a lower point across an higher elevation and ends at a lower point. So you need to provide a slab that is going to connect the highway to the bridge if it's an highway bridge. Then we also have some other kind of appurtenance like river retaining structures. So these are if the bridges is across a river. You need to protect your bridge so that as the river is flowing across the bridge, it does not really affect the functionality of the bridge. So all these are what made up of bridges, regardless of the type of bridge you are trying to design or you are trying to construct. So this image shows a typical longitudinal section of a bridge. So this is a truss bridge because the primary support member here is a truss. And then you see the approach slab. The approach slab is the slab that connects, as defined earlier, the traffic or the highway surface to the bridge surface. You see, we have it at the start of the bridge. We also have it at the end of the bridge. Then you can see the abutment is at the start of the bridge, and we also have abutment at the end of the bridge. Then you have river training structures. So these are structures that prevent your bridges from the river flow or the current flow of the river. Then you can see the riverbed. This is the piers. The piers that support the intermediate part of the bridges. And then we have the foundation. Like I've mentioned, this foundation is usually pile foundation or any form of deep foundation. And in exceptional cases, you can have shallow foundations as well, especially when the loading expected on the bridges are not as much as a standard highway bridge. So I hope with this video you've learned more about the structural components of bridges. You can check out my other videos on highway loadings and also structural loadings that we have, and other structural loadings that we have on bridges. Thank you for listening. Don't forget to subscribe to the channel, and then you can also visit our website chefjinacademy.com to learn more on civil engineering design. We have a quite number of courses that are going to help you in your professional journey. See you in the next video.